Hello, my name is Jeremy Martin. I am the Science and Operations Officer at the Weather Service office here in Goodland, Kansas. We've gotten a lot of questions over the past week or so about we had a very strong wind event move through Goodland on May 26th. Had a lot of great questions from people kind of wondering what happened, whether or not there was potentially a tornado embedded in there. And I really, after fielding all the questions, I really started thinking maybe it'd be worth doing a real quick summary of what we saw. This isn't going to be a very long presentation, and I am going to show some technical stuff like radar velocities and stuff. But if you're interested and kind of curious what was going on with this storm, feel free to listen. Hopefully I can answer your questions, and if not, you can always contact us on our social media platforms. The first thing to really look at is what happened across the area. This is a map of our local storm reports, courtesy of the Mesonet Iowa State site, which is at the bottom if you're curious about looking them up. You see there's a lot of various reports. The white circles with the purple background are hail reports. The red squares are tornado or funnel cloud reports. Had a couple heavy rain reports, and you can see a lot of those yellow boxes. Those are all damaging wind reports stretching from Kit Carson, Colorado, all the way up to south of McCook. So I had a pretty widespread area of winds that moved across the area. We had several reports of 60 miles an hour, several of 70, several 80-mile-an-hour wind reports, and I believe the peak wind we observed was just 4 miles west of Goodland. We actually measured 91 miles an hour. So a very intense area of winds came through during that evening. And as I mentioned before, one of the questions we get a lot of is, was it just winds? There is kind of a tendency when we see a lot of damage, such as in the picture here, to wonder, did winds cause that, or was there something else going on? These next couple slides, I'm just going to go through the radar and kind of explain to you what we see and what we think happened. But it's also important to remember that the phrase "just winds" is kind of misleading. We often think tornadoes can cause damage, but winds can't. Straight line winds can be just as damaging as tornadoes. That measured 91 miles an hour gust is equivalent to an F1 tornado. So please, if you take anything away from this little talk, is to not discount the threat of strong straight line winds. They can very easily do a lot of damage and be very dangerous. All right, I'm just going to let this loop play a few times. It goes between 6 to 6:40 p.m. Mountain Daylight Time, just to let everyone kind of get a big picture of what was going on in Goodland. We're the center there with the little little black hole there. That's not because the radar isn't working. It's just the way we plot our radar data. There's just a small area around it where it doesn't report any data back, and that's what you're seeing there. What you can see is kind of a big blob of thunderstorms moving into the area. If you look really closely, I'll try to highlight it here for you. You see this line like this arcing back. That is actually the gust front, or what we call the gust front of a thunderstorm. It's the area of much cooler, rain-cooled air that's kind of usually surging out for ahead of the thunderstorms. And you can kind of see that racing out ahead of these, well advanced of the actual echoes, right through Goodland, which happened to coincide about the time the strong winds came and the power lines started to get knocked over. Now from here on out, I'm just going to do some still pictures, just to kind of show you what was going on. Now, I don't expect anyone here to be an expert on radar analysis, but just kind of to show you some of the stuff we will see. What we have on the left here, I'll highlight it real quick. This is called radar reflectivity. It's usually what most people are common seeing. This is at the lowest level the radar can see, and essentially is things like hail, raindrops, things like that being reflected back. Yeah, that's a pretty common thing to see. And even at this time at 6 o'clock, you can kind of catch that area of outflow boundary right in there, which is really the leading edge of the strong winds. Here on the other side, this is a little more complicated to look at. This is called velocity. I'm sure you've ever heard about Doppler radars, how we can see how the winds are moving. This is actually how we visualize it. It's not a bunch of wind vectors or anything. It's actually just these color-coded, the greens and blues are moving towards the radar, the reds are moving away. The darker the blue or the darker the reds, the stronger the winds. It's pretty much like that. At this time, again, Goodland is right here. You can see that area where I highlighted where the gust front was shows up really well on the velocity as well. And you'll notice right behind it, the colors get really dark. In this case, we're pushing 80 to 90 knots, which is getting close to, at least at this height, um, close to 100 miles an hour in some spots of winds coming at the radar. Um, it kind of implies the winds are dropping off down here to the south. Um, it's kind of a radar artifact where you can't necessarily confirm that just because it's the way it samples, but it's it's definitely hitting an area of very strong winds there south of Burlington and Canarado. Okay, we're going to jump ahead to 614. Again, the reflectivity side doesn't look, at first look, doesn't look too threatening. There's your outflow boundary, your gust front. There's some stronger cells up to the north. This one actually has more of a classic severe look. You can even, if you look over here, you can see there's a little bit of a rotation there, but that's up by Bird City. That's not the cells that are coming towards Goodland. You go over to the velocity, and the same thing before. The gust front shows up really well on the velocity, but you start noticing just on the other side of this, around Canarado, Burlington, etc., the wind speeds are really strengthening. Now, granted, the farther away out you get, you're looking up higher and higher in the atmosphere. This isn't surface level. But this part in right here shows at Canarado, this time, again, radar was estimating around 90 knots of wind, which is getting close to 100 miles an hour. Okay, I'm going to zoom in a little bit more. And this is kind of focused on Goodland now, which will be in the upper right corner here. Just kind of looking at the reflectivity on the left, which doesn't show you a whole lot right now, and the velocity. You can catch a little bit of the leading edge of the gust front right there. I think where it really shows up well is over here, where you see is leading edge of enhanced winds. That is that cold pool that I just mentioned surging forward towards us. Probably if you were out there spotting when this was coming in, what you'd see would be a big wall of dirt, perhaps a shelf cloud, or a combination of both. And what is that? When you actually see that, what you're seeing is the visualization of that gust front coming at you with the rain behind it. And as I mentioned before, these purple values are getting above 80 knots to 90 knots of wind coming in, which is pretty impressive. Now, it's not right at the surface, obvious, but it just shows a potential for a stronger gust coming down when you get that kind of wind that close to the surface. I'm going to jump ahead to 637. This is actually after the storm moved through Goodland. Again, you don't really see a whole lot that would tell you that this is like a kind of tornadic setup. I mean, the cool outflow boundary is right there, following it down there. Lines up pretty well with the velocity. You'll notice the velocity changed colors though. Now the stronger values are these whites and yellows over here. That's because the gust front's actually moved to the other side of the radar, so now it's not moving towards us anymore. It's moving away from us, and that's why the colors switch right there at Goodland. Again, really intense winds on that side. It was still estimating in some spots 80 knots or so, which is very, very strong winds. But at least from a broad scale picture, it does look like what we saw coming was just a very strong gust front, along with a very organized issue. We call it something like a rear inflow jet. Very well organized, very strong, but at least at this point, it doesn't look like there was anything tornadic in it. Oops. But we did have a lot of reports, at least talking to people who were out spotting, seeing a lot of rotation as this thing came through. There was a lot of turbulence, a lot of dust blowing around. You could see, so that means you could see the way the air was moving, and there was a lot of dirt whirling around in different directions, which actually isn't all that uncommon when you have especially a particularly strong gust front. Now here again is just a picture of reflectivity. The gust front doesn't stand out all that much. It's running from there to there. Kind of your standard one. It's a big pocket of cold, dense air moving ahead of these storms. If you happen to change the velocity, though, we were close enough to actually see this. If you look really closely, I'm going to point out a few of them. There, and there, especially in here, there. You see those spots where either there's green next to red, or it actually looks like the line kind of kinks. And what those are very small scale circulations that are forming on the gust fronts. Sometimes they're called gustnados, things like that. They are circulations, and actually nearby, any spot near one of those might have slightly stronger winds in the areas further away. But they're not associated with any updraft. There's no storm pulling on them, strengthening them. like a tornado would be. They're strictly along the leading edge of that cold, dense air, which might have the visual appearance of a tornado. I mean, they will spin a little bit, but since they're not connected to the parent updraft, they're not really strengthening. They're just kind of there, if that makes sense. If you imagine just the rush of air changing direction so fast that it can create enough turbulence to start getting these little eddies. So if you're at spotting, I definitely think there's probably signs where it looked like there was rotation going on, and there probably was to some degree, but not necessarily tornadic type circulation. This was associated with something different, and really, even though those circulations could enhance the winds a little bit, just as strong as the large scale winds we were seeing, it really wouldn't have made much of a difference. But that's definitely something to watch out for when you're seeing a storm come in. And I think really the key takeaway, if you're a spotter having these questions, is what kind of clouds am I seeing with these circulations? It's one thing if there's a wall cloud and you see a circulation forming on the ground or around it. It's another thing, though, if it appears to be a shelf cloud and you see rotation out ahead of it. That's a totally different kind of situation. And really, if you see these things associated with shelf clouds, that your first thought should be that's downdraft, that's outflow. So it's probably not a tornado. And in summary, so we had a large area of at least 90-mile-an-hour winds that moved across some portions of town. There were some definitely non-tornadic circulations on the gust front, which would create very turbulent motion and kind of chaotic look when you're out there. And winds near these circulations would probably be a little bit stronger than they would everywhere else. I can't tell you how much, but it might have added 5 or 10 miles an hour to the top speeds. Thanks, everyone, for listening. This was kind of a longer talk. If you have any more questions, you can feel free to contact us on our Facebook page. We try to answer that as soon as we can, or tweet us at our Twitter account, which is at NWS Goodland. We're always here to answer your questions. If you have anything else you'd like to talk to us about, please let us know. Thanks.